Have you ever pondered what the ultimate fate of our universe might be? Will it end in fire or ice, or perhaps in complete stillness? These are the questions that have fueled the curiosity of humans for centuries, driving us to gaze up at the night sky in wonder and awe. In our quest to understand the future of the cosmos, we've developed various theories. Some suggest a universe forever expanding, stretching out into the infinite void. Others propose a more dramatic end, a catastrophic collapse in a big crunch. And then there are those who predict a universe slowly fading away, its stars one by one extinguishing, leaving only darkness behind. Each theory, in its own way, paints a picture of a universe governed by the inexorable march of time and the laws of physics. One such theory that's quite fascinating and potentially terrifying is the concept of the heat death of the universe. To understand the concept of the heat death, one must first grasp the principle of entropy. Now, entropy is a term that's tossed around in science classrooms and coffee shop debates, but what does it really mean? Picture this. You've painstakingly built a sandcastle. It's a masterpiece, every grain in its place, but as time passes, the wind and waves gradually erode your creation until it's unrecognizable. That's entropy. It's the natural tendency for things to move from a state of order to a state of disorder. It's the measure of randomness or chaos within a system. But entropy isn't just about sandcastles, it's a fundamental law of nature that governs everything around us. Consider an ice cube melting in a hot room. It starts as a solid, structured block of ice, but in the heat it gradually turns into a puddle, less structured, more chaotic. That's entropy in action. But why does entropy increase? Well, it's all about probabilities. There are simply more ways for things to be disordered than ordered. Think of it like this. If you throw a deck of cards into the air, it's far more likely they'll land in a jumbled mess than in perfect order from ace to king. The same principle applies to the universe at large. Entropy also has a direct link to energy. When systems change and entropy increases, energy is often dispersed. That's why your hot coffee cools down, the energy spreads out. So, what does this have to do with the fate of the universe? As entropy increases, energy is spread more and more thinly. Eventually, if this process continues indefinitely, we could reach a point where all the energy in the universe is evenly distributed. There would be no room for the stars to shine, no energy to fuel life. It's a chilling thought. In the context of the universe, entropy means that the universe is gradually moving from a state of order to a state of maximum disorder. Now, what does increasing entropy mean for the universe's fate? To answer this, we must first grasp the concept of the heat death of the universe, a fascinating and somewhat chilling theory. As the universe ages and entropy increases, we approach a state known as maximum entropy. Picture this. A universe where all matter and energy are spread out evenly, with no room for variance or gradient. This uniformity of energy distribution means that no work can be done, no stars can form, and life as we know it would cease to exist. This theoretical stage in the universe's lifespan is referred to as its heat death. It's not a fiery, explosive end as the term might suggest, but rather a slow, gradual fade into equilibrium. A cosmic balance where everything is the same everywhere all the time. It's a state of ultimate disorder. A universe that has shuffled its cosmic deck of cards so many times that every possible order has been explored and exhausted. But what does this mean for the future of life? Well, in a universe at maximum entropy, the energy required to sustain life would be scattered so thinly and evenly that it would be practically impossible to harness. Life, in the way we understand it, could not exist. Yet this doesn't necessarily mean the end of everything. It may merely signify a shift into a different state of existence, one that we can barely begin to comprehend with our current understanding of physics. While the heat death of the universe is a bleak prospect, it's worth remembering that this is just one theory. The universe has always been full of surprises, and who knows what the future might hold. Even in the face of such daunting inevitability, the beauty of our universe lies in its mystery and the boundless potential for discovery. In understanding our potential end, we gain a deeper appreciation of our existence and the intricate dance of energy and matter that makes up our cosmos.